Welcome to the Price Wall Podcast. It's March 30th of 2022, and we are honored to have Brandon Sojka of NutraShure and Dr. Hector Lopez of MPI Biosciences with us today. We are going to talk about OMEGAS because NutraShure has a new ingredient called SmartPrime, and it's going to help us take better advantage of our omega-3 status and do a whole lot of things to make fish oils and similar products even better. So welcome to the podcast, gentlemen. I'd love to have you give some brief introductions. I know you both have very legacy status in the industry, but let's do some brief introductions and let's just talk about the problem and how you're solving it.
Yeah, Brandon, go ahead. You want to go first and I'll chime in?
Sure, yeah. Like you said, founder and CEO of NutraShure. Been in the industry now for better part of almost 2 decades, and went from having my own brand at Myochem to being on the contract manufacturing side, doing consulting work, ingredient distribution, and then now obviously with NutraShure, having an awesome opportunity to be the first and the exclusive distributor of SmartPrime-Om.
And Hector's is a little bit longer, but I think we can.
I'll keep it brief. And then I'll send you guys a bio, and then you could always, I guess, pin that or something. Yeah. I know it gets funny sometimes, and then the more we do in the industry, right, the longer the bio gets. Look, I think just real briefly, I'm a physician scientist. My first real passion or love was sports nutrition, and then I got into more of the hardcore nutritional biochemistry. When I went into undergrad, I thought eventually I'd be working in industry. And then my dad ended up having some health issues late in my undergraduate years. And that brought me closer to medicine. And then I realized what a huge gap, this was in the 90s, what a huge gap there was in terms of, between conventional medicine on the one island, which seemed to have been operating almost on its own sort of island in its own swim lane. And there was really not enough crosstalk, I felt, with things that were happening in, at the time, exercise physiology, exercise science, nutrition, applied nutrition, even, room and opportunity back in the 90s for dietary supplementation. The technology now and the evidence base that we have now is enormous, of course, compared to back in the early and mid 90s. But that sort of brought me into medicine. And then I trained at Northwestern in Chicago. I did my residency there. I stayed there for fellowship, did a master's in nutritional biochemistry. And it was while I was there, while I was in med school, actually, I was already consulting in the industry. And lo and behold, actually, one of my first consulting gigs, besides doing some ghostwriting for some of the more preeminent sports nutrition brands at the time in the late 90s, early 2000s. Many of them have gone through acquisition since, but actually one of my first consulting gigs relative to what we're going to be covering here today was Nordic Naturals. So when Nordic Naturals first came on the scene, I was one of their medical advisors. And I was doing that while I was a resident. And then after residency and after postgraduate training while I was there, I really fell in love with finding ways to do clinical research and applying advances in dietary supplements. At the time, for example, I ran a small pilot study using creatine monohydrate in chronic stroke patients. And that was in 2004, 2005. And the result of that work ended up, basically many of the Chicagoland area hospitals brought in creatine monohydrate as part of their formulary. So you could use it with anyone in an acute rehab hospital who had a brain injury, spinal cord injury, a stroke, and general orthopedic rehab. So that was pretty cool because I was able to kind of cross over and bring something that at the time was really relegated as just a strength power supplement in the early 2000s, and a sports nutrition and a quote unquote bodybuilding supplement. I was fortunate enough to be able to bring that into clinical medicine. Fast forward after that, I went into private practice here in New Jersey, started off some pretty successful spine and sports medicine practices. Really was pretty unique because every office had a medical suite. We had a procedure suite where back then I was doing PRP and bone marrow aspirates and under ultrasound guidance. So we were doing regenerative medicine very early. This was in probably 2008, 2007, 2008, 9, 10. And then everyone was also getting a consultation with respect to how do you also apply, we were calling it nutritional optimization or metabolic optimization. Basically, how do you allow patients to get better faster? So they were getting chiropractic, medical treatment, they were getting procedures. We had a little bit of a strength and conditioning like PT gym in every office. So everyone was getting therapeutic exercise, working with PT, and then getting, basically nutritional supplement protocols. While they were in the gym, they would have access to some cocktails that I put together, which is, nothing that anyone now would say is revolutionary, but back then it was pretty unique, So we had hydroxylysine, hydroxyproline, vitamin C. We had some, back then we used Knox, good old Knox gelatin as our collagen source. And then I had an essential amino acid cocktail blend, which was basically provided the flavor as well, the flavored base. And then when you combine that with vitamin D and vitamin K2 and high dose fish oil, in 2008, 2009, it allowed us to create a big buzz in the community because patients, as you can imagine, they were being discharged healthier and feeling better and performing at a higher level than they were before their injury. So later on, I ended up divesting from the clinical practice, had a falling out with one of my partners at the time, and that allowed me to basically just put all my energy into the industry full bore. So in 2011, 2010, I partnered with Tim Ziegenfuss. We started doing clinical research together at our CRO, the Center for Applied Health Sciences. Shortly thereafter, also co-founded Supplement Safety Solutions, where we do regulatory compliance and nutri-vigilance or adverse event reporting, basically safety, post-market safety, like somebody watching the cookie jar, if you will, which is a federal mandate, but many brands weren't aware that they needed to have a system in place for that. And then in parallel along the way, that little black book of ideas and concepts for IP actually had an opportunity to use the lab in Ohio with Tim as almost like a little incubator, the mini incubator. So it was really, it ended up turning into an awesome opportunity. And it's, we've been living the dream ever since because it's allowed us to, develop and discover and commercialize new ingredients. We've got probably 5 or 6 others in the pipeline. We've got about 15 in the marketplace now. So it's been a heck of a ride, and it seems like there's a lot more left in the roller coaster still. So.
Well, so a lot of viewers or listeners in that case, will recognize Hector because of a lot of the ingredients that we already talked about. Your vasodrive AP or a few different we've talked about or referenced with you. But today we're actually going to be talking about an ingredient that very few people have spoken about at all. This is kind of a bit of a coming out party, at least at Price Blouse content with NutraShure SmartPrime. So I kind of feel like the best way to do this is just kind of to jump in and just start to discuss it. Is there any background that you want to cover before we start to talk about? I know we've talked about a lot of background already, but in terms of SmartPrime and how we get into the conversation of what it is and what it does for the community.
Yeah, I guess the best way to start, what problem are we solving here?
Yeah, no, it's a great question. So with SmartPrime, a personal friend and colleague and business partner of mine, Ryan Yates, he's a PharmD PhD. We kind of connected a few years ago through some other parallel work on dynamine and T-creen, actually. He was doing some PK work for us as a pharmacologist. And we started talking, and he told me about his interest in basically polyunsaturated fatty acid metabolism, PUFAs, right? So, for the audience or the listeners, PUFAs are part of the class of fats or lipids. Lipids can be classified into saturated fats or saturated fatty acids, of course. and they vary depending on the length of their chain. And the things that can affect how a fatty acid operates in the body are how long is the fatty acid, the length of the chain, right? Is it short chain? Is it medium chain? Is it longer chain? Within the short chain saturated fatty acids, you've got obviously butyric acid, you've got acetic acid, 2 carbons, propionic acid, 3 carbons. Butyrates get a lot of attention, clearly, as a postbiotic. And then you go into the MCTs, the medium chain triglycerides, from 6 all the way through 10 or 12, depending on who you read and who you ask. And then you've got long chain after that, right? So the longer the chain, the more solid that fat is typically going to sit at room temperature. And then you get into the unsaturated fatty acids. And within unsaturated, you have the MUFAs, the monounsaturates. The most common, of course, of which is good old lovely oleic acid, found in avocado, found in olive oil, of course, and many other nuts and seeds as well, but mostly in olive oil and avocado as a higher percentage of those fats. And then you have polyunsaturated fatty acids. And this is the category that omega-6 and omega-3s typically live in. And within omega-3s, you've got the shorter chain plant-based omega-3s, like alpha-linolenic acid, or ALA. And then you've got the longer chain ones that are found typically in cold water fish or marine organisms, from algae all the way to fish. So that's EPA, DPA, DHA, for example. Those are longer chain and they're omega-3. They have many double bonds, so they're unsaturated. The more unsaturated the fatty acid, typically the more prone to oxidation it is, but also in many respects, the more powerful it can be as a signaling agent in the body. So Dr. Smith, basically Ryan Smith, said, listen, I'm really interested in PUFA metabolism. And I said, well, that's funny. I mean, so am I, but I've kind of left it alone. I had left it behind me in a way, maybe 4 or 5 years previously. But I did have some ideas or some concepts that could eventually be IP, potentially, I thought. There was some things that I thought no one in the industry was really looking at that angle. He was looking at it from a very unique aspect. And he actually gave us access to the Oak Ridge National Library's supercomputer, and also access to someone who has developed a very unique engine, machine learning engine and AI engine. And, the way I like to say about, like, with AI, it's a buzzword. Everyone's using it. Many people are using it these days. I think many people get ahead of their skis when it comes to saying, oh, it's AI driven or AI based. I mean, if you use Google, you're using AI, right? I mean, if you're using PubMed, you're using AI too, to some extent. I think with the more powerful algorithms that are predictive, it's a little bit like getting handed the keys to a Formula One sports car, right? I mean, in the wrong hands, you're really not going to do much with it, right? And that's the thing with an AI engine. As powerful as it may be, you have to have great access to a heck of a database, which most of them can do. But then if you get this like readout or an output of an AI query, what do you do with that? That's where I think the expertise, subject matter expertise, knowing a lot of the biochemical and molecular pathways already, also having the understanding of the regulatory environment that we live in, you can start eliminating options very quickly and say, well, we know that's not going to be DSHEA compliant. We know that's going to require GRAS. Or it's going to require GRAS, but it's feasible, or it's going to require GRAS and we may never get it and spend 7 figures, right? So I think that was a very powerful opportunity for us to ask questions about where are there some gaps in the fish oil category. We felt like one of those gaps was why is fish oil not performing better? On paper, it should cure almost everything, right? But it doesn't. And so there were definitely some gaps, whether it's cardiovascular disease or cardiometabolic disease, or any sort of fatty liver disease, like NASH or and NAFLD, we felt like the data was just not panning out. So we used the AI engine to basically take a real deep dive into this category. And what we discovered was the reason why I think many meta-analyses when it comes to fish oil were disappointing. And you see those headlines all the time, right? Whenever there's a new study, that's a negative study on fish oil. The media is very quick to, jump all over that. Fish oil is a waste of time. It doesn't really do anything for primary prevention or heart disease or even cognitive function when supplemented. So we took a deep dive and we found out there were definitely some limitations, mostly related to the nutrigenetics of fish oil metabolism and polyunsaturated fatty acid metabolism. So that's how we arrived at SmartPrime ultimately.
So the issue is with the people that we're not able to process the omega-3s properly, or it's
an
modern environment
story.
Or like what?
Yeah. So Mike, it's an interesting story actually. So if you had the genotype that was present in sub-Saharan Africa and developed out of sub-Saharan Africa, as you can imagine, as a cohort, as a population, you didn't really have access to the coast, right? If you're in Central Africa, you're not getting to the coast anytime soon. But you still have a need, right, for EPA, for DHA, for DPA, for these really long chain polyunsaturated or highly unsaturated fatty acids. And typically, you don't find those in many of the foodstuffs that are around you in Central Africa, right? I mean, you may get access to perilla, get access to flax, sure. Even ahi flour, to some extent, you might get access to, right? And, for the listeners and the viewers, you guys know this, but those are short chain omega-3 fatty acids that the body will then need to convert into the business end, right? Into the EPA, DPA, and DHA. So what's interesting is if you carry a SNP or an allele that was very predominant from some sub-Saharan Africa, then you are actually going to be a hyper-metabolizer of polyunsaturated fatty acids. So what's fascinating about that is if you're fed a very wholesome diet, rich in flax, perilla, even if you get a little bit of access to omega-6 from animal meats, from some hunter-gatherer activity, even from grains, because your ratio is somewhat under control, right, of omega-6 to omega-3, even in that precursor form, you're going to be, because you're a hyper-metabolizer, you're going to make much more of the end products. And the end products, right, are EPA, DPA, DHA on the omega-3 side. On the omega-6 side, it's arachidonic acid, right, which is often labeled as the bad guy, the bad, pro-inflammatory fat, which there's more nuance to that as well, but we can dig into that later if you want.
So you're basically looking at it from like an evolutionary standpoint. Those that were in Africa really needed to hyper-metabolize whatever they could to get to. We need EPA, DHA for the brain development, fetal development, all that kind of good stuff. So they became really good at it because they're forced to evolutionarily, or that's kind of like the theory.
Correct.
That we run with.
It provided an evolutionary fitness advantage. It provided an advantage if you developed a genotype or a SNP that made you very good at making those end products.
But if I feed them a bunch of soybean oil, we're going to end up with a lot of ARA, arachidonic acid.
Bingo.
Okay.
You take that individual, you take them out of there and you put them in downtown Baltimore and you give them access to a ton of packaged goods and, to your point, right, omega-6 laden rich foods, and you don't give them much access to omega-3 or preformed, let alone preformed omega-3, EPA, DHA, DPA, you're in trouble because you've got arachidonic acid overload, essentially, right, is what you've got. Yeah.
Right. Okay. So what are you doing about this? And so is this ingredient just for those types of individuals, or are you just using this as an example to talk about?
That's a proof of concept. Yeah, that's just a way to get people to start thinking, oh, I see. So we have genes that create enzymes that allow us to actually still, people forget sometimes. And I was in the fish oil camp for a long time, right? So You hear this promulgated often. Oh, we can barely convert ALA to EPA DHA. Therefore, you just got to take your fish oil, just get the business end right, which makes sense, right? It does. It's a great tool. It's a great tool to be able to take in preformed EPA DHA. But individuals who are of Nordic descent, Norwegian descent, who did get access to the coasts, they don't carry at as high a frequency those same alleles, right? They're, relatively speaking, they're hypo-metabolizers. So what happens in their case is they're relatively protected from seed oils and omega-6 rich diets, relatively speaking, right? Relative to the individual who's like homozygous for that, those genes in Central Africa. They're relatively protected from a crappy diet that's loaded in omega-6. And then in those individuals, you give them just a little bit of EPA DHA and they become hyper responders to fish oil. But the individual, again, with those other hyper-metabolic genes, that doesn't do well with a high omega-6 environment, you're going to need to throw a ton of fish oil their way just to move the needle. And that, my friends, is why the data that we see is polluted, essentially, because nobody ever controlled for, very few studies have ever controlled for the nutrigenetics of the individual being enrolled in the study before they supplement them or before they randomize them to placebo or fish oil. You see? So in this case, what SmartPrime does is it helps to basically turn on that metabolic machinery, and it helps to right-size it and right-side it a little bit. So in the individual who does have, the suboptimal genetics, if you will, it will, relatively speaking, protect them from over-utilizing that omega-6 pathway, and it will leave the omega-3 pathway open for them to get more end product, more EPA, DHA, DPA from their precursors. And in those individuals, if you also add fish oil on top of it, then you're going to get an even more robust response in terms of an improvement in their omega-3 index. And we can talk about later on, not just improving the pool of omega-3s, but the packaging and the processing. What do you do with it once you're loading somebody with EPA or DHA? Now, in the individuals, the question is, well, then, again, to your point before, if I've got, normal heterozygous genetics, or I don't have that SNP, is there any point in me using SmartPrime? The answer is absolutely, because there are still additional benefits from the constituents of SmartPrime. Even if it did nothing to enhance your omega-3 metabolism, there's still some additional benefits of sesamin and sesamolin and episesamin, the lignans. There's still some benefits to getting methylsulfonylmethane in there, but together you're still improving the metabolism in other ways, not just omega-3, but you're increasing this cool, unique biomarker lipid that you're probably going to start hearing a lot more about, called LPC 18-2, which stands for lysophosphatidylcholine, and 18-2 is just 18 carbons long, and 2 means there's 2 double bonds. So it's basically linoleic acid, but it's loaded in this like lysophosphatidylcholine package. So that will still help and benefit anyone regardless of your genetics. And regardless of your genetics, we're still living in a very obesogenic environment, we're living in an environment that we're surrounded by that creates cardiometabolic insults almost on a daily basis. So those individuals would still benefit from SmartPrime. And then the third reason I would say it's important for somebody with even optimal genetics for PUFA metabolism to benefit from SmartPrime is you're actually able to do more with less. So you could potentially take less omega-3 in your diet. You could maybe get away with splurging on foods that might have a little more omega-6, and you'd be relatively protected if you're consuming SmartPrime at that roughly 500 milligram a day dose.
All right, I have so many questions, Ben. If you want to jump in before I go, feel free.
I wanted I'm excited to do the deep dive. I'm sure we're gonna go Inception here, but before we go super deep, at like a very surface level for the consumers who maybe won't understand as far as we're going to go, on a very surface level, what kind of difference in omega dosing are we looking at here? Like if you are taking a very run-of-the-mill omega-3 supplement, would you be expecting to be using less of it, like you said before, getting more out of less? What would you expect to see in there, like in terms of what you've already found data-wise?
Yeah, no, that's a great question, Ben. I think to take it more high level than that, instead of giving you a dose or a number of, an amount of omega-3 that you could get away with taking, right, and still seeing benefit, I think what I would do is basically refer you to some of the data that we do have for the patent that was some of the proof of concept data that we're going to validate in more larger human randomized controlled trials, which is imagine being able to not change anything about your background diet, right? So, or your supplementation status. So let's say you're supplementing with your 2 to 4 grams of EPA DHA from your favorite fish oil company. If all you did was add even 250 to 500 milligrams, there is a dose dependency here, but if you're in that range, 250 to 500 milligrams of SmartPrime, just add that alone without changing anything else. In 8 to 12 weeks, you could expect to see an increase in your omega-3 index, upwards of anywhere between 35 to 45%, just in your omega-3 index alone, just by adding SmartPrime. So I would basically say you don't have to change anything about your current strategy. Keep taking your favorite fish oil. Keep taking, if you're vegan, keep taking your algae or your flax, perilla, ahi flour, whatever you're taking. But if you just add this, you're going to go much further in terms of tissue levels, your pool of omega-3, the omega-3 index. And we could define what that means, but it's basically the percentage of EPA and DHA that's found in the outer leaflet of your red blood cell and your membrane, which is indicative that you can get from a blood sample. And that's indicative of what your omega-3 status is. And there's basically 3 main categories that you can fall in on omega-3 index, right? There's less than 4%, which means you're at very high risk for cardiovascular disease or cardiometabolic disease. There's 4 to 8%, which is kind of intermediate. And then there's greater than 8%, which is ideal and optimal. That's where you want to be. So you want your omega-3 index to be above 8. So with SmartPrime, if you're starting off, the US average is about between 4 to 4.5%. That's the US average population. So if you start off at 4.5% and all you did, even if you're supplementing a little bit, even if you're following whatever diet you're following, and all you did was add SmartPrime, you could reliably expect, it's what we're seeing, we're going to validate it, but what we're seeing is you could expect to go from, say, 4.5% to about 5.5 to 6%. So that's moving the needle substantially, and that's without, and that's dose dependent. So the more SmartPrime you take, you could potentially move that over more. We saw one of our subjects who was a relative responder, like a hyper responder, they went up a full 2.5 points. So they went from they started at 5 and they went almost to that optimal zone of 8%, 7.5%. So.
And how is SmartPrime deployed or used? What's the delivery? This is powders, capsules. We talked a little bit pre-call, but I want to record all of this. What different ways can we expect it to be used in products?
Yeah, Brandon, you want to take it?
Yeah, absolutely. So, this can be put into a soft gel with, if you wanted to do a combined omega-3 product, with a soft gel, you could do it as a standalone product, or, if you used a powdered omega-3, spray dried fat powder, or there's some other cool technology out there as well. You can do it in a capsule. It's very neutral in flavor, so it can be easily flavored around. And actually I have what's expected to be delivered tomorrow. We successfully got it into gummies as well, at 250 milligrams per gummy. So I'll get to try those tomorrow. So hopefully those taste really good. But yeah, you can pretty much, pick a type of delivery and you could put it in that.
Well, imagine for kids, right, with the gummy delivery. I mean, that's like, how hard is it to be able to get our kids to take, it depends on when you start. I mean, my daughters, we were popping Nordic Naturals soft gels in their milk back then. But no.
Well, Mike,
right, cool.
you're
so yeah,
clear
I'm
to
gonna
go.
stay. My questions are gonna stay like surface level at first too. So
Yeah.
basically, it sounds like we have an ingredient here. The constituents you mentioned real quickly. So it sounds like there's MSM, which was generally a sulfur providing joint supplement that clinically dosed usually around a gram a day or so. Sounds like you're pulling either you're using MSM straight or something from that, and then some extracts of like sesame seed oil, like sesamin and stuff like that. The question is like, so I'm assuming this is gonna be a patented ingredient of yours. So maybe we could talk about it a little bit. Are you actually like changing? We were talking a little bit about the genetics and stuff. Are you actually changing into the genetic coding, or are you actually just like providing precursors for the body? Like, what are you doing here?
Yeah, no, it's a good question, Mike. Yeah, so you're right. This first iteration. The patent covers multiple different lignans that we've studied from both black and white sesame seeds. It's really cool, actually, because like we've gone through animal seeds, and they actually each have a slightly, no surprise, right? It's what nature does. It's pretty cool. They have a different profile of like sesamin to sesamol to episesamin in that ratio of the lignans. And then we do use MSM as our choice of optimizing your methylation status. Most people use MSM as a way to deliver sulfur, like bioavailable sulfur. That's why it's used in, essentially joint health, connective tissue health, skin, hair, nail health, etc. But it also has some really some cool properties that I think often go underlooked, and we're using it as kind of a dual agent, as both a sulfur donor, which does some good things to general sulfur, glutathione metabolism, etc. But then we're using it as a methyl donor, because there's actually two methyl groups on the molecule. If you look at MSM, it's like, oh wow, cool, there are two methyl groups sitting there. And when you look at the chemistry of it, those methyl groups can easily be donated to your own methylation cycle that your body needs to utilize in order for it to be able to run a ton of different programs physiologically. So we use that as the blend. You asked about is there a way that, what was your last question?
I was basically like, so we mentioned genetics. Are you changing
the genetic
coding, or, that's obviously something that some are doing. I don't know if that's, dietary supplements, or are you providing the precursors, or both? Or
no, that's a good question. Yeah, no. So what we're doing here is the lignans that are found in sesame seed. What they do is those molecules end up interacting with receptors and with other transcription factors inside the cell. So what they do is they just work within your own genetics. We're not changing genetics. It's not a GMO issue.
Cool.
Yeah, nothing like that. All we're doing is changing essentially, the buzzword that everyone's using now as well, epigenetics, right? This is an epigenetic phenomenon. It's a nutrigenetic phenomenon, or nutrigenomics. We're changing the expression of some of those genes. So we're turning on some of the genes for D5D, that delta 5 desaturase enzyme. The elongase enzyme we can impact as well. These are enzymes that are part of that, let's call it the assembly line of your omega-3 and omega-6 metabolism, metabolic machinery, like what you end up feeding it, and then what you end up on the other side of the assembly line as the output, the end product. So it takes what you feed it, your body, your enzymes. Your enzymes are products of your genes. So we're turning those genes on, and we're allowing that machinery to take place more efficiently. So you can make more of that omega-3 end product with whatever input you're providing. Yeah.
Okay, so you're basically helping us, giving us the tools that it makes us better at processing the omega-3s. As we kind of asked before, is it also going to make me better at making arachidonic acid if I eat a ton of fast food every day?
Yeah, no. So here's what's cool about the lignins is these particular lignins, they interact with the active site, which basically means like the pocket that these enzymes contain. Enzymes are a catalyst, so they have a substrate, and then they change the structure of that They basically do chemistry. They're like active little um, chemical modulators or machines that allow us to speed up the process of whatever chemistry is available to us. So what's happening is these enzymes that our bodies make, they basically have like a pocket, and that pocket cannot be it can be occupied by an omega-6 precursor or an omega-3 precursor. And what sesamin does is it makes that pocket less amenable or less comfortable for an omega-6 to come in there and take a seat. And it allows the omega-3, like alpha linolenic acid, to come in and sit in the pocket and then get processed. So you're almost like preferentially speeding up the highway. You're basically cranking up the speed limit of the omega-3 lane, and then you're slowing down the omega-6 lane in the highway so that you're making more of the good end product that you want and a little less of the arachidonic acid. It's not a binary, on-off thing. It's always being modulated. It's like you're coaxing it in that direction. So I don't know if does that analogy make sense about the two different lanes?
Yeah, definitely. I mean, so one of the things you've kind of insinuated this, but like I want to make it very clear that I agree with the insinuations that the overload of ultra processed foods with the omega-6 polyunsaturated fatty acids coming from like soybean oil, corn oil, all these oils, processed toxic oils, in my opinion, cause us to have far too much linoleic acid. And there's a study published by Stefan Guyane. I'll set it in the show notes, and it showed that our fat tissue stores over the last few generations, obviously we've become more obese in general, but the fat tissue stores are containing more of this linoleic acid as well, like a catastrophic amount of linoleic acid. So my question is, a lot of the people who are interested in fish oils have cardiometabolic issues. They're likely higher in body fat as well, possibly obese. One of the issues in becoming unobese is that you're going to have to burn that fat, and out comes a lot of this linoleic acid. So I'm wondering if there is a diet application. Is this going to be protective for us? Because when they burn the body fat that has tons of linoleic acid, some of that can oxidize and cause all sorts of downstream problems, which is better to lose weight, obviously. But I'm wondering, like, the way I'm thinking about this is like, it seems very protective against some of these issues that are so prevalent in society and that aren't being discussed enough. I'm wondering, like, if you see if we see this as a diet application as well.
I would definitely see a diet application here, guys. I mean, basically, if you've got the metabolic health category, the GDA category, for example, which can kind of play in those right on those different sides of the fence. Sometimes people like to work on non-stim fat loss, body recomp, this would certainly be an ingredient in my sort of, I guess, palette of colors of ingredients. If you're formulating a non-stim fat loss product, or even a lipolytic product, if you add this in there, if anything, you're going to coax the liver. The hepatic thermogenesis may improve, because we do know even just the sesamin component of this alone, we do know it does some really cool things in the liver, like PPAR alpha upregulation activation. That's a really cool gene network that downstream of that, what you're doing is you're making the cells better at oxidizing or burning fatty acids, and you're helping to decrease triglyceride levels while you're getting healthier, while you're getting leaner. So yeah, I think to your point, this is a cool opportunity to get healthier while you're getting leaner, especially in individuals, to your point, that are loaded right now in linoleic acid and linoleate. So
yeah, okay. I'm like, I'm seeing this. There's a lot of stuff that you could do with this in the future. This is really interesting.
It has very broad applications, right? I mean,
I was almost going to say this was the doctor ordered, but I don't think I'm allowed to say that. So
yeah.
Okay, so I mean, those are the most of my questions. I know. So you, in general, you have 3 or 4 main bullet points that you have discussed in some of your articles, and there's a PowerPoint presentation. So if you want to kind of go into those, but I'm kind of starting to see where this belongs. And that's why I wanted to ask those questions and make sure that I understood kind of the mechanism. So I'm like fully on board with this. I'm excited.
Yeah, awesome, man. Thanks. So I think we covered a little bit of like some of the metabolic benefits, right? So anyone who's interested in improving their, let's say their markers of insulin resistance. And the other reason I'll mention that here is beyond what we've already covered. There's this really cool marker called LPC18-2 I mentioned briefly earlier. LPC18-2 is actually linoleic acid. It is a linoleic acid species of phospholipid. It's a phosphatidylcholine backbone. It's missing, the reason they call it lyso, it's because it's missing one of the fatty acid tails from the like SN3 position on the backbone. So it's got 3 positions on the glycerol backbone. One of them is the phosphatidylcholine head, the polar head, and then you've got a fatty acid in the middle, which is usually a polyunsaturated fatty acid. And that one can either be an omega-6 or it can be an omega-3. So if your diet is loaded in omega-6, you're mostly going to have that occupied by linoleic acid. So to your point before about Steve Guinness's article, like we literally are what we eat, right? Especially more so with fats, more so with lipids than probably any other macronutrient. I mean, when you think about it, right? Truly what you consume and the composition of fats in your background diet, in your macros, that will eventually end up becoming part of every membrane in every cell, in every organ and tissue in the body. So that's like a really heavy realization when you think about how you can impact or influence your health, your longevity, and your overall well-being, as well as obviously your performance, if you're interested in day-to-day performance, regardless of what you do. But there's also going beyond so the LPC18-2 has been such an important marker of insulin resistance. It's been part of these new panels like Quantos IR, which is a panel by a company called Metabolon that does some really cool work. They basically take like your blood, and their life's work is they take your blood and they do like this big profile or chromatographic spread, and they look at every metabolite that they can possibly find in your blood, and they try to then make predictions or associations. So one of those is like, what's the risk that you will become a type 2 diabetic in the next 5 years? And some of that work was done with Quantos IR. And LPC18-2 is one of those markers that is a big one. So the higher your levels of LPC18-2, the lower your risk of developing type 2 diabetes, even if you're pre-diabetic. And there's been some really cool work recently in the Baltimore longevity study, the BLS study, where 18-2 was one of the strongest predictors of your level of functional capacity if you had sarcopenia or if you didn't have sarcopenia as you got older. Your gait speed, like how well you're able to ambulate and walk over time. So one of the things that SmartPrime is doing is we've seen already in our data, and it's part of our IP, we're increasing levels of LPC18-2. So in addition to improving your omega-3 index, the one omega-6 marker that you actually want to see improve is this LPC18-2, because one of the areas it's huge in is mitochondrial health. So there's this this compound in the mitochondria that's very rich in the mitochondria called cardiolipin. And cardiolipin is a type of sphingolipid. Basically, the long and short of it is it's critical for how the electron transport chain functions in every mitochondria in every cell. If your cardiolipid status is not optimized, then you're not going to be very efficient or as efficient at making ATP through the electron transport chain. It's that last, it's part of what makes that ATPase at the very end of the chain, where you're bouncing around electrons and passing them off, and then you get to the end, and that hydrogen ion comes through, and at the end, it spins this complex through the inner mitochondrial membrane, and you get ATP. You make ATP and water at the end of electron transport chain. cardiolipin is essential for that like spinning channel, that transport protein, that ATPase, the enzyme that is the business end of electron transport chain, to work well. So LPC-18-2 is necessary. It's an obligate component of this cardiolipin, and that's part of why we also feel we're indirectly improving mitochondrial health. So it's metabolic health, mitochondrial health, which plays into all of these areas. And then there's cognitive, the brain. That's another area we can get into, which is there's only one way for DHA, which we all know is important for brain development, brain health, and retina, right? Eye health. There's only one way for DHA to get into the brain effectively, and that is through a transport protein that's at the blood-brain barrier. You can't just consume a ton of DHA and EPA and expect it to make its way to the brain. It doesn't work that way. The only way it can get to the brain is it needs to be packaged correctly. And that's the second thing that SmartPrime does is, one is it increases your pool so you can load more DHA, more EPA, more DPA in your tissues. But the other one is processing and packaging. The analogy here, it's kind of like Amazon, right? Everyone's familiar with Amazon now, or 3PL. If you put the wrong sticker on the package, or you put it in the wrong package, and then it never gets to its destination, right? Whatever you end up ordering. So here, for DHA to get to the brain, it needs to be packaged correctly, and it needs to be in that LPC. So DHA needs to be loaded as that fat in that LPC. Instead of it being LPC-18-2, like we said before, it needs to be LPC-22:6, which is DHA. So you can load DHA in that package, and now if it's in the blood as LPC-DHA, now it can get access to the brain across the blood-brain barrier. This is called it's the MFSD2A transporter. You probably hear a lot of people like Rhonda Patrick. She talks about eating like salmon roe in order to get like DHA. So it's a great concept, great idea. You can get choline, you can get DHA, you can get EPA. Problem is that the body doesn't work that way. You can't just consume preformed LPC-DHA and expect that it's going to get through your digestive tract all the way to your brain in that fashion. It doesn't happen that way. So the body actually breaks it off into its components and then repackages it after it's been circulating through the entire body and makes its way back to the liver, which is why you can't just depend on eating salmon roe in order to improve your brain's amount of DHA. You can get more DHA that way, and if you're metabolically healthy and your methylation status is on point and your homocysteine level's low and everything's working, then you can take that DHA and package it correctly and get it to the brain. So brain health, cardiovascular health, metabolic health. We even have a study, I'm not sure if Brandon let you know, we've got a study that's going to be starting soon for hair health, which don't worry, I'm not going to be the spokesperson for that hair follicle health study, but
I'm not the only bald one today.
Yeah, that's right.
Who's got facial hair?
That's right. So if it's for chest hair or back hair, I'm in. Definitely not. Yeah.
You mentioned before, and I think you talked about time a little bit, but you mentioned it's not an on or off switch. It is kind of coaxing in a direction. But in terms of effective time, you mentioned before the concept of like GDAs, which you take with glucose and it happens then. But we're talking about a few different benefits here. How long are we going to be looking to be taking this product before we see those benefits? Because that's going to play a lot into the products that we're going to be talking about as well. You were mentioning kind of like preventing the impact of fast food or whatever, but this isn't a product you could take with that fast food. This is a product you have to be taking for a while, is kind of what I'm putting together, right?
Yeah, this is not one of those acute, it's not like R-alpha lipoic acid, for example, right? It's not like RALA where it can work acutely. You'll need to take it over time and allow the nutrigenetics to do their thing. I will say that some of the immunomodulatory, anti-inflammatory benefits, I'm not making any claims, but I'm just saying there are some interesting immunomodulatory benefits. I guess decreasing inflammation related to exercise or as a matter of day-to-day activity. That inflammation response can be affected by the lignans that we do have in here. That could work within a matter of 3 to 7 days, even as little as 3 to 7 days, all the way up to 2 weeks. That can begin working, the anti-inflammatory benefits. But some of the other benefits, you're right, they're going to take 4 to 8 weeks at least. Yeah.
So you mentioned inflammation, surrounding training. Arachidonic acid is commonly used, actually on purpose, to increase inflammation from training. I promise I will only talk about hypertrophy for a very short amount of time here, but we have a lot of viewers.
It's cool. Let's dig in. Yeah.
We have to service the bro community for a little bit.
Sure.
Anytime we talk about antioxidants, peri-workout, we get all these people are like, well, if I take these antioxidants, it's going to ruin my inflammation, and you need inflammation to, cause muscle trauma and then recover from, which is all true and everything. And I understand this is not a yes or no question, but how much of an impact are users going to see on hypertrophy if they're physique athletes, or if, that's what their mind is on?
Yeah, I would, and I'm going to speculate a little bit here, right? Obviously, because we don't have the data yet, but based on what we do know, and based on how we know the mechanisms and the targets of how these ingredients work, I'm actually not worried about having a hormetic dampening effect on training from SmartPrime at all. It's one of the reasons why we're happy with its mechanism, right? It's because it's not like an NSAID. It's not like a non-steroidal anti-inflammatory. It's not like you're taking ibuprofen or aspirin where, you're going to get it affecting your prostaglandins, within a matter of hours, right? Because that's the whole point, right? People take arachidonic acid, just to kind of stay on that topic, because they're trying to increase the amount of a specific prostaglandin that we know has been linked to increases in muscle protein synthesis. Things like PGF2 alpha, for example, right? That's a pro-inflammatory prostaglandin that we know arachidonic acid impacts. Because this is just modulating, it's still permissive. In other words, we're not completely preventing your body from using or making arachidonic acid. We're simply kind of just trying to right-size and right-side a scenario that's already so overwhelmingly, tipping in one direction. I mean, I understand, and I've actually been a part of some of that research myself. I was actually a co-author on one of the papers on arachidonic acid in humans, right, for strength training adaptations. But I'm a little suspect, because I really feel like as a society, I think we've got more than enough arachidonic acid for the permissive effects that we're looking for after a strength training stimulus. I think we've got plenty of kindling, around us to be able to light up if we need to, right? I don't think we need to add that much more. But I do understand, obviously the theory and the potential application of arachidonic acid here. I'm actually curious to see if we see any impact on body composition where we might actually be able to, and again, I'm speculating, but we might be able to see a scenario where because we're impacting some of the pro-inflammatory catabolic aspects of training without impacting the anabolic side of things negatively, especially with respect to EPA, like combining a high-dose EPA product with SmartPrime. I think there's good data so far to suggest that when you add it to protein, adding omega-3 to protein, we know increases some markers of muscle protein synthesis, actually, right? That work's been done. Chris McGlory out of University of Stirling, some work out of Kevin Tipton, the late Kevin Tipton's lab. They actually showed when you add omega-3, Dr. Smith's lab here in WashU in Missouri, they showed that when you add omega-3, you can actually increase and do it with a clamp study, with an insulinemic euglycemic clamp study. You can increase markers of mTORC activation and muscle protein synthesis. And we think what's driving that is probably EPA more so than DHA, as far as, when it comes to the fish oil components. So So I'd say, yeah, for the bros, like, yeah, don't be afraid. This is not going to hold your gains back at all, from training. It shouldn't.
That's awesome.
I'm going to do my best to get as many of these studies into the show notes as possible, because you have so much information. We've wanted to get you on this podcast for years just so he could say. So, and sorry for cutting off Ben. So yeah, I mean, it would be an awesome thing to have you as a semi-regular guest, because you are a wealth of knowledge here. So thank you. Ben, I cut you off. So if you want to ask another question, you can. I was going to get back to like kind of the packaging of DHA for the brain. Is there anything that we're doing lifestyle wise that's making us worse with that packaging, or is that just kind of how it is, how it was, how it always was, and we're just trying to like optimize the human condition?
Yeah, no, it's a great point. So part of what we know is that when let's say all you did was just start supplementing with a high quality fish oil that's high in EPA or DHA.
And that's another thing. A lot of fish oils out there are not high quality and have plenty of omega-6 on their own. But interrupting.
Yeah. No, you're right. And I used to be a little bit of a snob in terms of like the form also, right? Like, it's got to be triglyceride or phospholipid or, the whole bioavailability, bioutilization. Look, I changed my mind based on available data. And honestly, over the last 5 years, I've changed my mind dramatically there. I used to be much more in favor of you should use a triglyceride-based form, right? That's how we've evolved to handle lipids or fats, right? It's triglycerides. But look, the data says otherwise, right? If you're running a race, then yes, your choice of the delivery of fish oil in a triglyceride versus ethyl ester versus phospholipid or free fatty acid matters. But if you're not running a sprint, if you're just worried about long-term loading, then it almost doesn't matter over time. Honestly, after 8 to 12 weeks, especially if you're consuming the ethyl ester with a meal, a lipid-rich meal, ideally, that's going to stimulate, bile flow and bile salt emulsification, that sort of thing. But what happens is I think getting back to your question about how it ends up impacting. You're saying how it ends up impacting. Remind me again what that question was.
Okay, so I was basically just trying to get a little more background on if there was like if there's a problem with the way we package our DHA to the brain.
Yes.
So we break ourselves.
Yeah. So here's what happens. So basically, after you consume your EPA or DHA, it gets absorbed mostly into the lymphatics, actually. It doesn't go directly to the liver the way most other nutrients do with first pass metabolism. And I think that's something that often confuses people. They don't realize these really long chain fats do not make their way to the liver first the way that short chain or even medium chain triglycerides do, right? They get access to the liver immediately in portal circulation from the small intestine, not with long chain fats, including fish oil, EPA, DHA, even ALA, even palmitic acid, anything above 12 carbons. It's got to be absorbed through the lymphatics, and then it gets dumped into something called the thoracic duct from the lymphatic system into the venous system. And then it makes its way through the body and then eventually gets its way back into the liver. So when that EPA or DHA gets into the liver, it has to be loaded as into something, right? And it can be stored as a triglyceride, in which case that's the package that it's stored in, and it's a lipid droplet. If it's in body fat, in adipose, it also will be stored in the lipid droplet within the fat cell. But in order for it to make its way and be delivered to the brain or to the heart or to skeletal muscle and other tissues, it needs to be part of a lipoprotein package. Hence, it needs to be part of like your LDL, VLDL, HDL, one of these lipoproteins. Or it needs to be become part of your membrane, your plasma membrane, your cell membrane. When it's part of your membrane or lipoproteins, that's where it's going to have to be in a package. Typically, these things get loaded as what's called a PE, or phosphatidylethanolamine phospholipid package. It could also be phosphatidylserine, phosphatidylinositol, other phospholipids, and phosphatidylcholine, of course. But usually the first step, it gets loaded as a PE. That's like the reservoir. The problem is if you have if you're metabolically unhealthy, if you're overweight, you've got insulin resistance, if you're if you have an issue with like folate metabolism and your homocysteine levels high, or you're vitamin B12 deficient, or your methylation status is not good, then what happens is it gets sequestered. It almost gets stuck as that PE when you load it, and then it can no longer move into the PC form, which is ultimately where you want that DHA and EPA to end up. Because if you wanted to participate in all these wonderful responses, you know, the prostaglandins, the anti-inflammatory stuff, all the benefits, the business end of fish oil, why we take fish oil to begin with, from cardiovascular to heart, to, you know, full body health, anti-inflammatory, joint health, etc. You need to get it into that phosphatidylcholine form. So what happens is if you're unhealthy or your methylation status is inadequate, you get stuck in that PE package. So we need to move it to the PC package. And the way we do that is by having some sort of a methyl donor. In this case, we use MSM as our methyl donor, but our IP and our patent, and we've done studies in animals that shows that if you use you know, B12, folate, B6, B2 combo works great. If you use betaine, trimethylglycine also works as well. But it actually didn't work as well as the MSM. That surprised us a little. It was almost like a little side IP that we established from the MSM. And you're delivering sulfur, which is important as well in its own right. Does that make sense about the PE versus PC? Like if you're not healthy, you're going to get sequestered and stuck.
Yeah, and those are the exact people who are probably going to be told to take fish oil more often than not too. So we find ourselves in these situations that need correcting. That's really cool.
And you know, are you guys familiar with that study that was published, the VitaCog studies from EU, from Oxford University? It's basically the study that showed they have a patented blend of B6, B12, I think it's B6, B12 folate, and then I believe it's also they add a fish oil, which can come from any source, but it's mostly the folating, the methyl folates and the activated B vitamins in a VitaCog study was shown to actually, as an intervention, increase the volume of the hippocampus and also of the cerebral cortex, the gray matter. And the reason we feel that's happening is because they probably tapped into the same mechanism that we tapped into here with the methylation status. You're probably able to get more of, with those B vitamins intact, you're able to get more of that PE DHA into the PC, which can then deliver it to the brain and then help with neurogenesis and maintenance of gray matter and brain volume over time. So I think that's a cool little like connection to be able to make and connect the dots and say, oh, that's why methylation status is also important for the brain. Not only all the neurotransmitter stuff and everything acutely, but over time, the brain needs B vitamins to be able to get your EPA and DHA in the right package, so then you can get it into the brain.
Okay, no, and so can you spell that out? VitaCogs, or what was it?
Yeah, VitaCog, like VITACOG, like VitaCog, okay. Like vitamin cognition. Yeah,
it'll be in the show notes once I find it. Thank you. Okay, yeah. So interesting. You're putting together a lot of stuff that, you know, obviously we don't cover fish oil as often. I don't think a lot of people have gone down these rabbit holes. So we appreciate
trying to connect some dots. Yeah.
And so it sounds like there's other ways to do this, but MSM ended up working better. That's pretty cool.
Yeah. So that's like a little additional, side, you know, sort of hack that we found.
All right. Can I ask, this is a little bit more of a Brandon question, but where we're going to find this in the market? Obviously on our show notes, we will note every place forever as it's live, but as of this podcast here, I'm assuming we'll see it kind of working its way into Omega products. There's obviously a larger group for it, but as of March 2022, every time we do one of these where we talk about a new exciting ingredient, everyone wants to know where they can find it right away. You know, people who are trying to find it now, what should they start looking for?
Yeah, so currently the main products that are out on the market, if you're looking for a combined fish oil plus SmartPrime product, there's two out. Well, one is actually it's in the process of being here. So I'll say that it's available. But so you have the Leviathan Omega, which is already out. and then also Life Force, their Omega also, like I said, should be available any day now. So those two are your fish oil. Also, DNA Health has an Omega with it as well. If you want to look for it as a standalone to really kind of take it with, maybe you're happy with your Nordic Naturals fish oil or whatever brand that you're using, DNA Health actually has their Omega Optimizer, which is pretty much SmartPrime plus estrogen in it as well. There are some pretty big players, one of which that I know is imminent on launching. I can't disclose who, but you'll know about it here within the next month or two.
We'll obviously keep it live for everyone so that it's rolling, but having that standalone one is going to be really popular for a lot of people who are already happy with their Omega, obviously. So that,
well, and another good, sorry to cut you off there, but another quick benefit with that too is, a lot of our data actually showed that even without the consumption of an additional omega-3, right? So let's say maybe you have an allergy to fish, or you want to kind of stay away from, you realize that like maybe the vegan versions or ALA and stuff, aren't as optimal, whatnot. We actually showed that you're seeing a benefit with SmartPrime by itself. So you are seeing, the benefit of it. Obviously it takes it to another whole level when you combine it with an Omega, but at the same time, you still get some positive benefits by as a standalone product.
And so as for consumption of the ingredient, do you guys have any data on like when it's best used with? Is it, you mentioned estrogen, so I'll ask if that helps specifically with it. Should it be with food, or, what's the best environment to be taking the product?
Yeah, I mean, I would say, and you can add in as well. But I mean, again, because it's a lipid-based, ideation, I would be consuming it with meals. Hector, you can add in a little bit more if you feel that, on an empty stomach, or what time of day is better. I think that's probably, you can get a little bit better advice on that one.
Yeah, yeah. I think the timing isn't as critical, which is nice, because the important thing is that someone's consuming it over time. The nice thing about these lignans is, even though they do really well in a lipid-rich environment, so with a fatty meal would be great, the lignans, unlike fatty acids, are a little more soluble, and so even if you take it on an empty stomach, it might not be a bad idea either, because if it wins the race, if you will, to the liver, it's sort of ready. It's turning on the machinery so that when the fatty acids arrive, it can do its thing. But again, that's just speculating about like timing. It's almost like creatine timing in a way, right? It's like, just get it in, find a way to get it in. If you want to get really into the weeds, then possibly on before your meal, like when you're still empty, so that it wins the race to the liver, to hepatic circulation. That might be a good way to consume it. And then if you're going to go AM versus PM, again, it's probably going to be marginal as long as you're getting it in. But if you want to be optimal based on like the circadian, what we know about the circadian rhythm in terms of how it affects like chronometabolism, like how the liver behaves in the morning versus later on in the day and overnight, with respect to circadian biology, I would probably prefer to take it in the PM. So maybe before dinner, for example, would be a great place to take your 500 mgs.
Awesome. Well, speaking for myself, I got a lot of I got a lot out of that hour. I don't have any questions left. That this has been really illuminating on the topic. So this has been perfect for me. I don't know if Mike has more to investigate.
I don't. I mean, yeah, it's putting together. It seems like this is one of those situations where the Omegas didn't work out as well as anyone would have liked over the last couple of decades. And this is going for a solution, or a partial solution, or something better. And that's important to me. And just the fact that it may help steer bodies in the right direction, especially for these diet applications. I'm very, very interested in this. We're going to be covering this a lot more. We're going to have some deep dives. I'm going to do my best to have like a lot of these studies. I've already found a few of them in the show notes and everything, but I want to write down and keep it up to date as well. Like, over the coming months, full articles, and probably have you review them as well, really just diving into this stuff, kind of start topically like we did here, and then get deeper, and people can skip over the deep stuff that they need to, because this is important. And And I think a lot of people are kind of becoming very aware of how important it is, as you know, what we've been doing in this society has not been working the past few generations. So anything that can kind of steer us in the other direction, I'm all for.
Awesome. Yeah, I think there's one other thing, like a little nuance on the dose of, even though it's still proprietary based on the IP, the dose of the lignans that's in here is much higher than what you're going to find. I think there's one other brand that I saw that's using a lignan at like 5 to 10 milligrams or something in their fish oil product. And that's really more there for to prevent peroxidation, because it does actually help to do that. So one of the cool things about having the SmartPrime in at this dose is it's going to deliver the kind of lignan dose that's been shown in some clinical populations to have some benefit as well. So when you look at some of the clinical data that's been published on sesamin, again, without making clinical claims, obviously, or drug disease claims, there is some data there that suggests that it works at higher doses than what's currently been used in the industry. So we were fortunate enough to secure and source a very reliable high-end sesamin lignan complex. Yeah, here. So, and it also keeps the fish oil that it gets mixed into fresh. It almost acts as, like how you'll find tocopherols and rosemary extract for freshness for fish oils. Mm-hmm. The sesamin here of SmartPrime will also help to do that as well.
Cool. All right. Well, don't want to take up too much of your time. I know how valuable it is and everything. What we're going to do is we're going to have priceplow.com/NutraShure, NutraShure, as a place where you can look at all the news and all the things that we've tagged with NutraShure over the coming months as people listen to this. And then you can also sign up for the alerts there so that we notify you when there is something new that is NutraShure based, whether it is Ben talking on YouTube, us talking about a product that has it, this podcast, or other new products that contain the ingredients that come from NutraShure. It sounds like you have more coming as well. So I'm on this ride. So I'm very excited about this.
Awesome. Yeah, SmartPrime is only the first of multiple that we are in the process of launching. So stay tuned for more. So we have some cool IP that's coming out later this year.
Excellent. Thank you, gentlemen, so much. Anything else?
Thank you, guys.
Where can we find NutraShure on social media? Is just at NutraShure?
Yep. Instagram is at NutraShure. LinkedIn, NutraShure as well. Same thing with Facebook. So those are our 3 social sites. Obviously our website, and looking forward to it.
Awesome. We've got a lot of content coming with you guys, and we'll be looking to reprise this again for the new IP that you guys have coming, because I'm sure we'll want you guys to speak for yourselves. Awesome.
Sounds great.
Thank you guys for your time.
Cool. All right,
Thanks, guys.
Take care.